Hello, good evening. Pranjay, are we all set? Abdul Rahman, Jason, Mario, Mithun, Mithul, Nitash, good evening. How are you all today?
Yes, sir, we are all set.
All right, good. So we can start off then. Great. So we are in session 4 of supply chain logistics analytics. A small portion of total cost of ownership. What I want to do is that that's more like optional. So what we'll do is that we'll cover the network design optimization and then get back to that portion because that's quite small. Right? This is significant. I want to cover this and then we will go back to that. Yeah. All right. So today we are going to be talking about network optimization, network design and optimization. And leave it. That's not needed. Right. So what we covered was inventory classification, safety stock, inventory optimization, and then what we have remaining is a TCO part of it, which is not part of the main topic, but I put it in as because that's one of the good concept to know about. We'll try to cover that as well briefly tonight. What we need to cover today is facility optimization, network optimization, gravity model, and route optimization. We'll see them one by one. They all kind of cover the situation of when you set up a warehouse or a DC or like a factory. How is the connection happening between like the point of supply to the point of consumption and the route thereof. Before that, let's quickly try to take a look at the term end examination. When is your term end examination due? When is the term and examination due? Term and exam. Weekend of 3rd, 4th December. Okay. So we have some time, I believe, right? 3rd, 4th, 5th December. Okay. Okay, that's good. So and the good 2 weeks. Fine. Good. So the key topics that we want to cover and before that, the term and examination is going to be a 3 caselets 20 marks question, 3 into 20 marks, and it will be a brief case situation will be given. Based on that, you are expected to cover some concept, meaning apply the concept and give the explanation. There will be marks breakdown for the sub question. We are not guided by the words, but still for you to have an idea of how much to write, about 600 words is what you could be writing, but don't worry about it. Don't keep it too brief. You need not keep it too elaborate. So if you're going to talk about 500 to 700, 800 words, that is perfectly okay. Some people tend to write a lot. Some people are too brief. When you're too brief, you're not able to apply it. That is the only concern. Else, like it's only as a matter of the guide point. What I want you is to focus on the topic of the question. Whatever is the question, hi Vishnu, whatever is the topic of the question, that is what you need to be focusing on, right? And which means that in case you are covering some topic which is not the main focus, ensure that you're not running yourself out of time, right? So make it, structure it in such a manner that you're introducing the concept. When there's a question about a concept, let's say forecasting method, introduce the concept of forecasting, briefly talk about quant call, if that's a question all about. And if it is asking for applying a situation to either 1 or 2 or 3 methods, apply them, right? And then logically explain why is that method or how the application happens, etc. And if need be, conclude. This is what you need to be doing and structure the answer in such a manner that you are able to put a title, a subtitle, and the details for the answer. These are the focus topic: forecasting method, accuracy measures, roles of inventory, classification, which we covered, safety stock, MOQ, EOQ that we covered, total cost of ownership. In case we are able to cover, otherwise don't worry about it. I'll take that off, right? Facility optimization, 2 methods we'll cover. Network optimization, 2 methods we'll cover. and a small understanding about responsiveness and efficiency. So across the 4 session, this practically cover the entire, like the key concepts. If you are able to focus on it, you have enough time. If you can go through it and try to get some good understanding, you could be good with your term and examination. Any question, Abdul Rahman, Jason, Mario, Mithun, Mithul, Monica, Nitash, Vishnu? Are we comfortable here? Any question? Okay, well, then with that, let's move on. Sorry, some people, some comment. Oh, okay. Thank you, Mario. Appreciate your question. No numerics are expected. Thank you for that. Yes, it's a very valid point. For clarification, no numericals are expected. So it won't be a numerical question. See, that is why, Mario, we're talking about forecasting. The numerical work, hard work is all for the system. For us, it's all about the concept and application. Okay. Right. Fine. So can we move on? No other points? Okay. Right. Fine. So what are the key challenges in supply chain management today? Very briefly, that is also. Jason, there are 2 attempts. So can you reach out to the support team? Yeah, there are 2 attempts. One a trial and one an actual attempt. Yes. Can you please do me a favor, reach out to the support team, and maybe they are able to either maybe there's some timing issue, whatever it is, they might be able to help you out there. Can you? And you're done with the work, with the trial, yeah? Jason? Well, I think you need to be not the hardware support team. I think the support team at Upgrade is whom you should go to. Whoever about the course content and the same team. I think it's an Upgrade one, not the, yeah. Okay, right. Fine. So, what are the challenges in today's supply chain? Some of them. One is there are a lot of SKUs. Today, we are really talking about a large variety of SKUs, a lot of items coming into the portfolio of an item, and different stock keeping strategies, different demand patterns. That is what we covered, right? MOQ, EOQ, different types of demand, bullwhip effect. That's what your simulation is all about. And that calls for different types of classification that we looked at. So that safety stock, fluctuation, demand, throwing the entire thing off balance. So these are the things that we need to be, thinking about, right? And number 2 is the high lead time resulting in increased supply variability. When the lead time is actually quite long, there is more supply variability happening. Maybe you will also see it in your simulation. Because of that 2 months, 8 week, whatever is our 4-week lead time, then you're really having a lot of supply variability as well, because we don't really see any force majeure kind of the variability. But the point is that when you really have the kind of, like the longer lead time, chances are that what you placed by the time demand varies and you're not able to get the supply, you're not able to flex your supply, change your supply within time. And other thing is inaccurate demand forecasting due to complex channel structure. Apply it again to the beer, root beer game, because there is no visibility, there is no communication in the channel structure. There is inaccurate demand forecasting happening. Demand will be quite fluctuating, right? And the next point is about right deployment strategies with the product and where to keep the stocking location, how much to keep. Should we really plan for more stock, less stock, which location to keep stock on? Those things are the other challenges. It's about the last point that we probably will be covering bit of our discussion today. That is what we are talking about, the network optimization, etc. Okay. Any questions so far? That's a kickoff. Any question? Are we good so far? All right. So now, let's try to cover a bit of background. This is actually coming from a async module. One, we are talking about Apple. Apple, the largest production as of now. China, we know that Foxconn is coming up with more investment in India, etc. But largest production hub, 95% of the value is being manufactured is in China. Okay, and from China, world over, goods are going through. So just imagine the kind of the supply. How is the facility located? What is the kind of the distribution network, etc. Next one is Samsung. Samsung had the production facility in China. They shifted the production base to India, which is the largest producer currently, right? India is the largest producer for Samsung, and they moved away from China due to the fact that, the reason I'll go straight away, due to the fact that, the market in China was getting too price competitive for Samsung, and there were other low cost, low price providers, competitors for Samsung. So they were not able to compete well with those brands. Yeah, local brand. Yeah, Apple fully subcontracted, but they really keep a close watch on. Things have been working well for them, but Apple, as you know, is with Foxconn, correct? And Foxconn themselves are slowly scaling down their footprint in China, and they are moving to Taiwan, and they are moving to India. You're aware of it, right? Did you read the news article about that? It's not new. It's not a new one. Have you seen that strategy? Clear? Any thoughts, comments? Yeah, right. So that's why, that's a background for the channel distribution network structure. Oh, look. Okay. Now, we'll take one more example, maybe that we would have covered in the operations supply management. So here we are talking about Marks and Spencer, right? We are talking about the cost pressure for Marks and Spencer. They went to China, around the year 2000. And then that was the time most of the organizations were going the China way. And what they did is that when they moved to China, they were actually originally producing in US and European markets. They closed, not the markets, sorry, in the markets, but in the main subcontinent, they closed those outlets and they moved over to China, because that was making sense for them to be handling at that point in time. Eventually, as more players moved to China, what really happened was labor rate advantage diminished. Yeah, transportation was getting more, costlier, because China was a low cost production base. As many people moved to China, demand for the manufacturing facility over there rose up. Hence, the advantage in the production cost went down, meaning the labor cost went up, advantage went down, because all the people were transporting. So as of now, we are having the container shortage. Similarly, it was not a shortage situation, but a lot of demand, automatically freight goes up. So China, freight went, transportation was longer, freight went up. The balance of trade was also leading to not imbalance, but basically currency fluctuations. It was not getting favorable most of the time. So that was another reason why, when they really moved, there were a lot of hidden charges, hidden costs, which made the benefit less and less significant, right? Another issue was inventory. A lot of inventory, longer lead time, more inventory. Inventory became an issue. And another software aspect that really played a role in the Marks and Spencer in the distribution network, or facility optimization, network optimization, was that carbon footprint was getting into an issue. People were asking for carbon neutral products, and Marks and Spencer, being a kind of, they play in the premium market as well. When they really have to cater to the requirement of the people who are asking for carbon neutral product, it becomes quite a challenge when goods have to be traveling a long way from China to European or US market. Further down, quality issue. When you are in a place like China, which is much more, or Far East generally, which is much more price competitive, quality issues are quite normal, right? Because there is cutting the corner. Unless you really keep a close watch, some kind of shortcuts happen, and you get the quality for the price that you normally pay. When you pay less, you have to definitely be happy with lower quality as well. And another issue that happened was intellectual property related issue, copying. It's not legally very strong, or they have a legal system which much more suits the local country, rather than the global scenario. Hence, IP issues, infringement related issues were there, which nobody is able to contest in China. So these were the reason why they moved to China. They moved back. I think I've covered the reasons, so I don't want to take for the discussion anyway. Some new people joined and others were there. So Rajat, how are you doing? Purva, how are you doing? Krishna Kumar, how are you doing? Good. So clear on the Marks and Spencer case. And we have a similar situation for Hornby Hobby. They also went the China way. Same situation around the same time. They did exactly what the Marks and Spencer did. They also shut down the UK manufacturing plant. 10 years down the line, around the year 2010, the same issue, competition, and this is not even premium, right? Toys. So customers are not willing to wait for long lead time. And it's fashion, it is fad. Marks and Spencer is fashion, this is fad. More time, what is happening. So production cost advantage was also diminishing for them. Because of all those reasons, they also shifted the base from China to UK. When they came up with the Airflix, a new toy range came in, they shifted the base from UK to UK from China. Because although it was high cost, all the hidden cost was actually playing a spoil sport in the bigger picture. So that is the background about Hornby Hobby and Marks and Spencer, right? So these cases we covered briefly only to talk about when you really have your plant located in a far off place, what is the implication in terms of the cost, in terms of the what you call the price, in terms of the cost and the lead time. Not only that, how various other hidden variables, even the macroeconomic variables, can affect your business, like exchange rate, like the IP infringement, etc. Okay. Any question? Now we'll try to take a look at the network structure itself. Any question? So Richard, everybody okay? Fine. Did you all get the Excel file? Abdul Rahman, Jason, Krishna Kumar, Mario, Mithul, Monica, Nitash, Purva. Hi, SC Prakhar, Dogra. Hi Prakhar, how are you doing? And Surajit, Vishnu. Did you all get the Excel file that I uploaded? Okay. See, normally we give it for the working. If you are not able to work along and we are just watching the screen playing together, that is also okay. You can keep those Excel file in case you want to plug some number, change it, and then play around. You can do that. Yeah, that is only to give you a flavor. We won't be using any number, like Abdul, Prakar, Vishnu, others, Apurva. We won't be using these questions on one of the models. There won't be any numbers involved. It will be giving the situation just like Marks and Spencer or Hornby Hobby, and then we'll have to kind of, apply the logic and then come out with probably a potential solution. So there won't be any numbers involved. Numbers we are showing in Excel only to give an idea about how certain things really play around. Okay. Right. Now, let's try to understand what is a network. Okay, very good. So network consists of demand centers. So when we really talk about, Hornby Hobby or Marks and Spencer, they have customers in Europe, maybe Far East itself, maybe in Asia, maybe in USA. So those are all the demand centers. And where are they manufacturing? See here, wherever it is, just as a pictorial view, they are manufacturing somewhere in 3 locations, and that's basically the supply center. And the route the supply takes is what we call as a distribution network. Yeah. So demand center refers to the location or cluster of existing or potential customers. And supply center refers to the point from where the supply originates. Distribution network is the flow of the goods or the path that the goods take, including different modes. This is 3 important elements in any network. So all the models that we are going to be looking at considers these 3 things. Where is the demand? Where is the supply coming from? And what is the path it is going to be taking? Are we clear on demand center, supply center, distribution network? This particular slide, keep in view, because this is something you probably need to understand. What is the demand center? From where? Group of customers, clusters of customers, etc. Supply center, place from where the product has to be supplied from, place of origin, any intermediate facility, etc. And distribution network talks about the flow of the goods or the product using connecting the supply center and the demand center. And it also talks about what different modes of the transport. Now, is the question, is the supply center and the demand center only talk about finished goods? Question number one. Can a demand center be a supply center as well? Vishnu, Purva, Abdul, Prakar, Monica, others. Can. Yes, perfect. Yeah, Mithul, Vishnu, yeah, Abdul, can be raw material. So I'm getting raw material from, so Foxconn is manufacturing in China. Are all the raw material Chinese or made in China? Maybe Chinese is not even a good word. It's not wrong though. Yeah, no, right, Jason? Yeah. So Foxconn is a supply center for what, Jason, Vishnu, Abdul, Mithul? For the finished good, right? Now they are a demand center for raw material. Clear? So a supply center, and can there be different routings as well? The flow can also be more upstream, right? From a supplier to the demand center makes it and supplies it further down. Clear? With that, we'll try to take a look at the facility optimization as one of the theoretical points. But before that, I think we covered this. Supply chain network includes demand center, supply center, and distribution network. There are two types of decision that we need to take in terms of a network or other facility optimization. Strategic decision. This is from your async module. So the same thing visually. They are required when it comes to changing the structure of the supply chain network or setting up a new network. Here you're talking about changing the network or setting up a new network. Strategy. What is tactical? Related to the existing supply chain network, right? And that do not really require any change. You're only, rather than supplying goods from point A, you supply from point B. So Foxconn in China or Samsung plant in India and in Vietnam. Normally India supplies. There is a supply plant in Vietnam anyway. Normally India supplies, but demand is high. Hence Vietnam also supplies some part of the demand. Clear? So question. Yep. Correct. Market MACD is a supply center to demand center throughout the world. But Mithil, what happens is that MACD could be having, demand center. See the outlet. Yeah. The outlet, normally most of the items are locally sourced. Correct. So which means that the demand center or the outlet will try to get the sourcing as much locally as possible. So it is not a global supply chain. Mithil, point is very good. MACD has global presence. Exactly. Like more ready-made food, so it's local suppliers generally. Yeah. Even packaging is local. Their branding and other things are local. Staff, uniform, local, right? And the furniture. So most of the things are locally made, right? As in the sourcing is local. Now, yeah, but they are actually an organization which has global presence. Clear, Matul? Yep. Now let us quickly take a look at some of the Unilever changing the network, closing down some facility, and they centralizing the Dow, fabric, cleaner, etc. in UK, in Germany. What decisions that? Strategic or tactical? Strategic or tactical? Strategic, right? Because they're shutting down, new network happens. Clear? All right, moving on. 3M having the 3M, what we did was we shut down, not that we shut down, we moved, we set up a new plant in UAE, and whatever was part of the production from Turkey was moved to the new plant. Strategic or tactical? Strategic, very clear. Setting up new network comes into place. SKF, what they did was they did inventory optimization without affecting the customer service. One example we're taking a look at, right? They kind of leverage the distribution center in such a manner that they optimize the inventory. Strategic, tactical. It was more about playing around with, with the thing. They did not do any setup or whatever. Hornby hobby that we saw now. Tactical, strategic. Strategic, clear. Marks and Spencer, method. Others. Strategic. Yep. Zara procuring the local materials and fabric and the facility from the local market. Strategic, tactical. They are only, they have plant in, Portugal and in Spain. Depending on the volume, they decide whether they produce in Spain or in Portugal. They're not setting up anything new. Jason, maybe I didn't clarify that. Yeah, Jason, who set strategy? Jason, Monica? Yeah, okay. Monica, are we good? Jason, thank you. Monica, are we good? Monica, are we good? Maybe, yeah, I didn't clearly explain. So yeah, it is not that they try to source. They have the plant, they only engage which one to go. Jason, Monica, are we good? Others? That's good. Thank you. Fine. What else? Do we have any example? Apple using Foxconn, only one facility. New demand center come up also. They use that facility to supply. Strategic, tactical. They decide to go to tactical. Yeah, tactical. Strategic in a way, Mithal, yeah, you're right. It may be depending on how you look at it. If it is, let's say that we are getting into mainstream Africa, and then I am supplying directly, not on a cash basis to a distributor, then you can call it as a strategic one. There's nothing wrong. Yeah, that's fine. That's fine. Purva. So even if you really call us tactical, wherein there is already a wholesaler dealer network existing, and I'm only kind of allocating some stock to them, then probably it is tactical. Yeah, so it's fine. Some of them is quite on an overlap. Good. And IKEA setting up plant in China and supplying to getting to local market by from the workshop in strategy. Samsung moving from China to India. Yep, clear. I think most of them happens to be strategic. I should change the example, but it's fine. You all got the flavor of it. That's what is needed. Good. Alrighty. So with that, let's move on. Anyone new joined? Oh, okay, very good. Now, what time is that? That's good. Very good. I think we are fairly on time. 2 half an hour. That's fine. Now we need to be taking a look at the 2 models. We'll take a look at the facility optimization, within which we'll take a look at the network optimization and gravity location model. And in this model, so 2 things you need to be keeping in us. Let's go one step at a time. You need to keep in mind these things, like in the facility optimization, it talks about network optimization and gravity location. We'll be talking about a route optimization, facility allocation. We'll talk about it subsequently. So now we are talking about the facility optimization, which has 2 models, network optimization and gravity location. Now, what are we talking about? First thing, we'll be talking about the network optimization model. So what are the 3 components of a network? 3 components of a network. 3 components of a network. Demand, okay, correct, Abdul Rahman, but you're right. Demand, supply, distribution. Demand, you're right, Matal, Abdul. Demand center, supply center, distribution network. Okay, I believe you understood it. Yeah, you quickly type, that's fine, I believe. Yeah, demand center, supply center, distribution network. Okay, right? Who was that? Mithul, Abdul? We are good there, right? Yeah, correct. I think Mithul wrote after that. Mithul. Okay, that's good. That's fine. So now in the facility optimization, network optimization model, what is that we need to be keeping in mind? This is from your async module. Okay, so it is exactly the same visuals that I've copied and put it out here. So anyone referring over there will see the exact visuals. Some question? Okay, good. So one is that what is the plant capacity? So when Samsung is moving to India, one of the things that they would have decided is that what is going to be my plant capacity? How big is that? Right? And am I going to be setting up one or many or more? Many as in there can't be many, but one or a few. Yeah. And it also depends, right? When you set up a plant, is the cost of setting up a plant in India, multiple places, the same or different? Is a plant setup cost the same or can it be different in different places in India? Different, right? Now, next point is that I need to decide, what's the capacity, what is the cost, and what are the demand centers I'm supposed to be catering. Take a look at the Samsung example, reflect upon it. Samsung had the demand center not in China, it was in India. Supply center was in China, right? They felt my demand center is in India and I'm spending a lot of cost in shipping the goods. I don't have a lot of demand here. So why not I as well move my demand center, supply center to India, look at the supply cost, look at the demand centers, where else am I going to be supplying? Maybe Europe, USA, that they were supplying already from China, and maybe some portion to China and good portion to India as well. So you need to identify which are my demand centers. And when you talk about a demand center, from China shipping to USA, Europe, from China shipping to India, now you are in India, from India sending to different places to China local market. So is the cost, logistics cost not changing? Overall, is the logistics cost structure not changing? Yes or no? Is the logistics cost structure not changing? Yeah, that is what we need to be keeping in mind. Else, what is the point? Why did Hornby Hobby and why did Marks and Spencer move to China? Because they were subcontracting. There is no cost of setting up a plant. It was all logistics cost and the production cost. Yeah, that's the point. They had the demand center still up in Europe, in USA, hence logistics cost was high. Okay, right. Now, the steps that we need to go through is that this is a very logical way. Are you clear with this point? Is it anything that is not sounding logical? So even if, like what's the type of the capacity, what's the plant I'm going to be setting up, and what's the capacity, what is the, like where are the demand centers and what's the logistic cost? Logical, correct? Anything complex here? All right. Now, there are a couple of steps that you need to follow. If at all there's a question, I don't expect you to be writing exactly the same step in the same order. Similar here as well, but you need to be logically presenting these things so the concepts are covered. Okay, you need to be expecting some question because very strong concepts. So like I've listed the topic, so chances are that this question around these. Yeah, and but in this particular point, you should be clear with the concept. That's all. It need not be exact wording. It need not be the exact sequence, but the concept need to be covered. When you talk about logistic cost, you really talk some other cost. It doesn't make any sense. Similarly, when you're talking about the setting up a plant, you can't be talking about a different cost. So those things conceptually will have to be covered. All right. Fine. Next is the steps that we need to follow is that when you're talking about network optimization, you need to know where are my demand centers and what is the forecasted volume. So when Samsung moved from China to India, they would have kept in mind what is the likely volume that will happen in India. Maybe they knew already, yeah? Or they are going to be exploring the market further, expanding it further, right? Next, identifying regions for locating facility, considering various policy constraints. So when IKEA moved to China, Chinese government was giving them tax holiday. When Samsung moved to India, they were taking a look at various places. Couldn't they have moved to Sri Lanka? Couldn't they have moved to Pakistan? Couldn't they have moved to somewhere in Taiwan? But they were looking at the area around, and they looked at India, keeping in mind various policy, ease of doing business, etc., etc. Okay. So one is demand center, region where you can actually get the new facility. Number three, what is the capacity and the cost? What is it depending on the demand? Maybe they can, demand is, let's say, 1,000,000 unit. I can set up a plant in India for 500,000 and a plant in Taiwan for 500,000. Is it not possible? If yes, what's the capacity I'm talking about? And what's the cost related to it? Fixed cost related to the plant, and also the variable cost. See, when Hornby and Marks and Spencer went to China, the variable cost was low initially and it started going up. That's the point. Yeah. Identifying the logistics cost between various facilities, option, and the demand center. See, they would have really taken a look at, can I set it up in Taiwan? Can we set in India? Can we look in Sri Lanka? If yes, what capacity can we do? What is the fixed cost? What is the variable cost? Yeah, if it is in point A, from here, different demand centers, what's the cost? Those things need to be looked into. And you do an optimization to arrive of the total cost to arrive at the facility where you should be setting up your plant or warehouse or whatever it is. This is what is network optimization model. We'll try to take a look at the Excel now, and any questions so far? Are we clear with the concept? Conceptually, are we good? Are we okay with the concept? Okay, good. Anyway, when we take a look at Excel, it might be all the more clearer. Network. Here you go. So, is the Excel file clear to all of you? Is the Excel file visible? Okay. All right. So, let me close these things. So, what we are talking about, network optimization, right? So, what are the things that we need to be keeping in mind? We need to understand what are the potential supply locations. Yeah. So it can be Maharashtra, Karnataka, Kerala, Rajasthan, Punjab. Okay, you decided. Now, these are also the demand centers. Huh? See, I have to supply Maharashtra, Kerala, Karnataka, Rajasthan, West Bengal, Punjab, Delhi, and Orissa. So these are the demand centers, and you have chosen some potential candidates wherein you can put up the supply. Is that clear so far? So you determine the demand center and you determine the potential candidate for the supply center as well. Are we good so far? Then what else do we need? We said we need to understand the demand, right? Forecast. Did we say that we need the forecast from the demand center? So demand center, supply center, what is the quantity demanded in the demand center? Yeah. So that's the quantity. 40,000, 12,000, 32,000, 30,000, 15,000, 17,000, 20,000, 8,000. So these are all the quantity demanded. Okay. Right. Now, next point that we spoke about was, we'll talk about this, but we'll cover this and come here. Okay. What is a fixed cost? Fixed cost for, and then fixed cost, this is actually for a depot and this for a distribution center. So the possibilities are that in Maharashtra, You can either set up a depot or a DC. See, don't worry about it, because see, this is depot, DC, this is only for the purpose of simulation. It can be a plant. Logically, how you need to understand is that, which place are we going? Is it manufacturing or distribution? If it is distribution, how big? What is the fixed cost? What is the capacity? That's all. Clear? Okay. So the simulation talks about, somebody, some question. Yeah, the depot, see, that's why it is more about a small DC, large DC. See, at times in such things, we also try to make it complicated with our semantics. Now, when I read it, I myself are wondering, we could have made it actually a small facility, large facility, because there's not a real case scenario. We are only creating one for understanding. So we can keep those things simple. In real life, when you do it, Mithil, it'll be complicated. That's fine. That's understandable, because outside world is complicated. But this is inside world. We could have made it simpler. So I'll make it more simpler next time. You are right. Depot is a small one. DC is a large one. Hence, the fixed cost is also higher. Capacity is also higher. Did you see that, method? Yeah. Are we good? Okay. So what are the points that we looked at so far? Very quickly. What all have we considered? Which model are we looking at? Which model are we looking at? Trust me, if we follow and we, yeah, in the facility optimization, correct. In the facility optimization, what particular model? Network optimization. Yeah, network optimization, right. And what all the questions should we be asking in the network optimization? Demand center, supply center, fixed cost and variable cost, logistics cost method. So we need to identify which are the demand centers, what's the demand, which are the potential supply center, and what's the fixed cost of setting up a facility, right? Large facility, small facility, forget it, right? And what capacity of the facility are we looking at? Last point is about what is the variable cost. So you're talking about the production and logistics cost here. Okay. So you're talking about the production plus logistics cost of supplying from, this is supply region, yeah. Maharashtra to Maharashtra is 6.3, thousands per million. Per million? No, per thousand. So 6,300 per thousand units, which is about 6.3 rupees or whatever it is per unit. Clear? Or per thousand unit. Right? Are we good here? So we are talking about supply center, demand center, quantity demanded. In the supply center, how big a facility are you setting up? What is the capacity of the facility? What is the fixed cost of that facility? And what is the variable cost, which is the logistics cost of supplying from each of those facility option to different demand centers. Are we clear so far? Anyone, any question? Is it complex? Understandable? Yeah. This is a fixed cost. This is a fixed cost of setting up a facility. See, when you are setting up a facility method in a location, there are two costs, right? One is the fixed cost of setting up a facility. And once you set up the facility, every time you're supplying or getting a supply, there is a variable cost of the production and also logistics. Yeah, or maybe your question is not complete, I believe. Yeah, Mithil, go on with the question, please. Hold on. Are we talking about this one? Cost associated with the plant? Whether to set up a single plant with high capacity or multiple, yeah, that's fine. So you can even go with the cost, because when you're talking about setting up a plant, Normally it's about the fixed cost and the variable cost is operating. Okay. So yeah, you're right. This is actually fixed cost, not the cost is good, but associated with the plant. Yeah. Logistics cost is variable. Correct. Correct. Absolutely. Hmm? All right. Now, what is our objective? We need to be now, what is network optimization all about? Where should we setting up a facility? How do we decide that? Based on all these costs and the capacity and the demand and the logistics cost, you need to be finding out if one location or combination of location which will meet the demand and do that at the minimum possible cost. Are we clear so far? Are we clear? Which are the combination of facility? Yeah, okay, good. Now let us do that. How do we do it? We can go to solver. Well, solver is not the only thing. Solver is not the method that you are going to be using this in real life. Okay, let's solve it. I don't want you to be remembering any of these things. So long as you understood whatever I covered so far, that is good. So now let us try to understand. The demand from Maharashtra is 40,000. So where are you setting up? You are setting up a DC in Maharashtra. You are setting up a DC and a depot in Karnataka. You are setting up as a DC in Kerala. There's a depot in Rajasthan. There's a depot and DC in not Punjab, Punjab. Okay. Same Punjab. Right. What happened? Now, what is supplying where? Maharashtra is supplying Maharashtra, Rajasthan, and West Bengal. What are we setting up in Maharashtra? A DC. What's the capacity of the DC? 50,000. See, 40 plus 7 plus 3, 50. Right? Similar. That's how we need to understand each other. Yeah, please. Nitash, in your Excel, you're not able to take binary. Let's check it out, please. Data, solver. All right. Oh, no. Cancel. Data, solver. We go here. Add cell reference. Bin binary. When you do this, you should be able to get it. This is okay. Good. Yep. All right. So now, right. So what is the cost? This is the cost, huh? Whatever is the value. Too large a value, not able to. All right. Okay. Can we now what do you think? This is the ideal solution. This is the optimum solution. There's excess capacity in Kerala, right, of 5,000. What will happen if we add more condition? Will the cost be less or more? If we add more condition, yeah, Mithil, Nitash, yeah, more the condition we add, the cost will be more, isn't it? Right. Okay. Any question? Are we okay, or you want to try any condition and do, or can we move on to the next one? Are we okay? You want to put any condition, one more limitation, and see whether the cost is going up? Next is going to be gravity location. Yeah, very good. So now, based on the optimum cost, what was our objective? Our objective was to meet the entire demand. Okay. And then the whole network optimization tries to meet the demand by setting up facility, large and small, in various locations, trying to minimize the total cost based on the combination of fixed cost and the variable cost. Okay. Solution was to set up a DC in Kerala. Whereas and to which all markets is the Kerala DC supplying to? To Kerala itself and to Rajasthan. Rajasthan, what's the total demand? 30,000. So Rajasthan is being supplied from Maharashtra, from Kerala, and from Rajasthan itself. Okay, now coming to Kerala. So Kerala is supplying to Kerala and Rajasthan, where the total demand is 27,000. And what are we supplying? A DC. What is the capacity of a DC in Kerala? 32. So 27 minus 32, that's a 5,000. Yeah. 32 is the capacity, but based on the optimum number, we need to supply only, 27. So that's the remaining 5. That's the remaining 5. We have some capacity after optimization. Now, what happened is, Mithal, if you try to optimize that 5,000, then it will be a suboptimum solution because you are force changing something. Now, what will happen in case the capacity cost is more? We are not considering that. If you add that as a cost, maybe the solution will change. Got it? More, but in reality, that is what happens. It is not as simple as what we see here. But yeah, this still is a good representation, no doubt about it. Yeah, but then cost, there are more dynamics. That's the point. Are we good? Can we move on to a gravity location model now? Is the network optimization clear? I will stop share. I will close this and we will go to gravity location model. But before that, very quickly, you're talking about facility optimization, in which there is network optimization and gravity location. Network optimization talks about identifying potential demand centers and the forecasting, identify potential candidates for the supply center and any policy constraints to be looked into. That's not in the Excel. That is much more for you to understand conceptually. In the supply location, what is the kind of capacity are we talking about? And then we need to understand the fixed cost and the variable cost. Now, whose question was that, Mithul? That variable cost is the logistics cost, Mithul. Okay. And then identify the fixed cost is actually setting up the facility, and then variable cost is basically running the facility. Logistics cost is the cost of moving the handling, transportation, etc. Right? Then based on all these things, you find an optimum manner of where all do I set the facility, one or combination, how big, in such a manner that you reduce the total cost. What are the costs? Logistics, fixed cost, variable cost of the facility. That is what network optimization model is all about. Variable cost for the facility is not about the logistic cost alone. Logistics cost is more about the logistics between demand center, supply center. Variable cost is the cost of operating the facility. You set up the facility, fixed cost, you put people, you put equipment, machinery, that also could be part, but then depreciation, etc. could be variable. And even the cost of operation is variable. Are we good there? Are we fine? Mithil, are we good? All right. With that, we will move on to the next topic, which is gravity location model. Samsung wanted to move out of China. Okay. What do you think? When you really apply network optimization model, would they have decided on India straight away, or would they have compared various options? Taiwan, Sri Lanka, India, China, not China, probably that's where they want to exit, and various other countries. What do you think? Various options. That's network optimization. Based on that, they felt this Kerala, Maharashtra, Funda. See, that only talks at a state level. Is it really telling where in Kerala, where in Maharashtra, where in Rajasthan? Is that answering that point? Is it answering or no? No. Right. So that's a network optimization where in that network, not answering. Correct. Thank you. So now gravity location model answers that question method. That really talks about, oh, I need to set up in India. Very good. But where in India? Got it? Is it a rural area? Is it an urban area? Then what will be the variable? Fixed cost in setting up a plant or DC in an urban versus rural, which will be higher? Fixed cost. Possibly rural is lesser, right? Rural is lesser because land is cheaper or whatever it is, right? Operating cost. You don't know. Maybe urban operating cost is definitely higher. Rural probably it is lesser. Transportation cost. Maybe rural is more. Why? Because it has to go much longer. See, I'm not saying this is high, this is low. That's not our objective. Our objective is that based on various combination, the equation could change. That is what I'm trying to conclude here. Got it? Okay. So just like the network optimization model, in the gravity location also, we need to answer and understand various concepts. What are those? One is that the transportation cost. So now we are talking about the network optimization model has answered the question of where. Over there, now we are deciding which location. So this really talks about transportation cost per unit, an estimate. It can't be actual. That is one of the limitations of this model, because as the coordinates change, see, between a small change, it won't be different. But if it's a long change, it's going to be different. There's another aspect which I'll come later. Location, GPS coordinate. Where exactly do I really locate? Yeah. Number two, quantity movement between demand center, supply center. These are the questions to be answered. Now, is it too different? So what additional point has come in the gravity location model? What additional point has come in? Coordinate. Absolutely. Absolutely. Conceptually, it's the same. We all want to meet somewhere in the campus or somewhere in Mumbai. Where in Mumbai? That's GPS. That's gravity location model. Okay. Now, identifying the regional for facility location based on the network optimization model. So what does it say? Gravity location model is an extension of the network optimization model. Network optimization talks about the region. Where within the region is what gravity location model tries to answer. Good. Next point. In the selected region, identify the supplier and the demand center. Over there also you need to understanding, right? Maybe the demand center is already known, but you need to be feeding that in the model as well. Yeah. So what are the potential supply center? Sorry. It's not about potential supply center. When you really set it up, goods are coming from different places and going to different places, correct? Yeah. So you need to be mapping where are the goods coming from, where are the goods going out to. So based on that, you will get a midpoint. What else? I think I mentioned that. Okay. And identifying the logistics cost per unit, the same. When you're talking about moving the goods, you're talking about the logistics cost. cost of moving the goods. And you do the simulation. Normally a tool will do it. Trust me, solver we are only using to demonstrate. Solver is not, see in simple situation, solver is okay. But normally when we ran something for our Saudi warehouse, it was a proper tool that we used. Okay. Then you optimize based on the inbound and the outbound logistics cost. Is the concept clear? So two facility optimization model, one is network optimization model, the other one is gravity location model. And the second one is that in the gravity location model, you start with the network optimization model, the region. Within the region, you try to understand where am I getting the goods from, where are the goods going to, and find out the, like the coordinates of the supplier and the customer. Identify potential cost of moving between those centers, a rough estimator. I'll talk about it subsequently. It won't be a perfect estimate. That then you really optimize it. You will be able to get a coordinate wherein you can get the you can set up the facility. Is that clear? Any question? Abdul, hi Avneet, how are you doing? Jason, Krishna Kumar, Mario, Mithun, Mithil, Monica, Nitash, Purva, Prakash, Surajit. Who else? Surajit. Vishnu, are we all good? All right, good. So now we need to get to Excel. All righty. Before I get there, let us take a look at this gravity location model. Okay. Right. Now, is the Excel visible to all of you? All right. Yeah. It's visible. Okay. See, I have not put anything up. Now, this is what we need to understand. So where am I getting the goods from? I get, see, it's an import facility. Yeah. So I get goods from, Kandla port, JNPT, and also get goods from Chennai port. Where are my supply center or demand centers? My customers are in Mumbai, Nagpur, Pune, Nashik, Jaipur, Kolkata. Okay. What's the quantity I am moving to? I'm moving 25 tons, 1,000 tons, or whatever it is. Anyway, that's besides the point. And what are the coordinates? The coordinates in Kandla, 75, 750, latitude, longitude. Oh, that's on even scale. Don't worry about that. That's on even scale, probably not the actual number, doesn't matter. And then Mumbai 100, 300, etc., etc. So this distance is really talking about 0 x coordinate to 0 75 y coordinate, right? So this minus that whole square plus y coordinate minus this y coordinate whole square. That is what this number is showing. But we need to find out what is the actual x and y coordinate of an ideal location based on the cost. What does it take on this particular cost? What does it take on this particular cost? Do you calculate it beforehand, or is it dependent on where the location is? Is it calculated beforehand where the location is? Yeah, correct, Avneet. See, that's one of the limitations of this particular model, but it's fine. The formula doesn't really care too much about it. It's only talk about an estimate. Now, based on these demand centers, let's try to understand what is a potentially good location. Okay, how do you do that? Data, solver. Then it is really talking about optimizing D21 by changing what 17 and 18. Minimize the cost. Yeah, solve it. Say okay. Alrighty. So talking about the cost, ton, and the distance. Yeah. So now based on this, based on this location of the cost changes, you can change it. Then the amount will change. That's the only point. Okay. All right. No. Solver is something you need to set it up, and it is only for demonstration, Amit. It is more exam or whatever it is. You need to set that up in case you use it at work. Otherwise, probably it is not needed. Excel, we are only trying to demonstrate here. Okay. Now, what does it say? It says 194,460 is the ideal location where we should set up the facility within the region. Okay. Where is 194,460? Somewhere in Pune. Near Pune. Yeah. But the point is, Mithal, when you say somewhere near Pune, if it is really far off and it doesn't really have any, infrastructure support, will that be a good idea? Right? So what do we do? Let's say that I will set up somewhere not here, somewhere more close to Pune, maybe one. Let's actually, for the sake of it, I say 175, 400. See, the cost changed, but that's still okay. The model, although with the limitation, is giving me an idea on where I should be setting that up. Now, since I know the freight, this is where I want to set it up, or this is where it makes geographically to set up the facility, I can relook at the freight. I can probably change it, and I can kind of fine tune it. Is that clear? So it is, the model has limitation, but it is quite indicative. It can give you an idea. When we did two situations I know, wherein we did something for Tangier. I don't know whether we've spoken in OSM, wherein we got the location should be set up somewhere. See, Tangier is in Morocco. The tip from where you can actually see Spain. And the facility was not coming to Tangier because we're also supplying Algeria, Tunisia. So somewhere, like midway is where it was coming to. We can't set one up because that's outside the free zone. When we are doing the exactly same thing for our Dammam, Riyadh, Jeddah, we got it somewhere midway between Jebel Ali and Dammam. You can't set something up. Hence, we stayed in, in Jebel Ali. Are we clear? Is the model okay to both of you? Facility optimization, and we are talking about network optimization and gravity location. Yeah, correct, Mithal. See, that's why this is actually an estimated one. So let's say that now it is 1.7 rough. Yeah. So these things really change. Okay. And the JNPT 1.5. Yeah. Sorry, the question. As the number has been fixed with some reference. Yeah, it was fixed with the based on the previous run reference. But what you can do is that you can actually keep it as null and you can run it. Let's say that we keep it as null. You run it, and then what can be done is that solve. Yep. Oh, did I change? Then you can actually plug that in as well. Yeah. Correct. It will only be giving an indication because correct. So once we really know an idea, so we'll have to do one or two iterations, Mithil. Practically seeing what happens is that one, it will be giving you a location which is really offbeat. And number two, maybe it is not Pune that I really want strategically. So probably it is Mumbai that I really want for some other strategic reason. So this model will give an idea in the network optimization, the region, within the region, what all possible places, but you'll have to take an overriding decision by, like tweaking certain factors. There are things like factor rating method and all, which we are not covering here. That is another area wherein you take a look at what facility is available. Yeah. And then what are the various factors? Do we really get manpower? Is talent available over there? Or some of the customers will want key customer. I want a facility near me. Oh, that's an added advantage. You keep in Mumbai, not in Pune. Yeah, those things as well. But for the cost part of it, to answer your question straight, for the cost part of it, yes. After you run it, you'll have to tweak a bit and then recheck it. On without limitation, what's the cost? With the limitation, what's the cost? Then you can understand, is it reasonable? Do the sanity check. Be good, Mithil, others, gravity location model. Everybody quiet today. Are we good? Vishnu, Surajit, Prakar, Monica, Mithil, Mithun, Mario, Krishna Kumar, Jason, Avneet. Everyone okay? Was it tough weekend? Meaning long week and a weekend. So battery is really down. Is that one of the reasons? With me as well. Huh? Yeah, I can imagine. So don't worry about that. Yeah, take it easy. Yeah, that's fine. It's a concept okay to you. Don't worry about the number part of it. I'm only trying to demonstrate it because it will become pure theory. So this will help us understand a bit. That's the only idea of putting some, yeah. Oh, no work from home. Okay. So commute as well. Huh? So take it easy. Are we okay, Krishna? The concept is clear to you, correct? Otherwise, go through the slide deck. It will be fairly clear. It is a very simple thing. Logically, take a look at it. And then if there is any question, feel free to reach out to me. And you have some time before the exam, so you can always post a query and get back to me. Yeah, I'll be more than glad to help. Yeah, correct, Monica. And look, Excel part of it, the practice, like if you really want to play around and understand, that is where it comes into place. And then why we have put the Excel is to demonstrate the actual one. Yeah. No. You won't be expecting this, Avneet, but what you will need is that, let's say that, Avneet, you're talking about let's take an actual case of Samsung want to exit out of China. So how will you be talking about the facility optimization? That's a question. Then you need to be talking about straight away, they are taking a look at, network optimization, wherein they are going to be deciding among Taiwan, among Sri Lanka, among India, among maybe some other place, even Africa, deciding where to go. What all will they consider? They'll be considering all the factors like demand center, supply center, the cost of setting up a facility, fixed costs, variable costs, transportation costs, etc. That's a network optimization model. Okay, Avneet, once they have the network optimization model, and based on that, if it happens to be India, then they need to be deciding where in India. Because network optimization model, we're talking about the potential region. Where in India is then answered by, within India, where am I getting the material from? Where all am I going to be sending the goods to? What is the GPS location like this? Yeah. And what is an estimated cost of the transportation from the source to this particular point, estimated one, potential location, which you don't know. Yeah. Avneet. And what's the volume that you're getting, importing, and you're exporting? That because that's about the supply and the demand. So no matter whether you set up in Pune or Nashik or Nagpur or Mumbai, that volume will remain the same. It might change, but for the sake of general understanding, see, the customer demand won't change whether you have facility here or there, right? It's stable. That's what determines, right? Then you try to optimize that by running a simulation. Need not be solver. You can even do it mathematically by hand. That is what gravity location model is all about. Are we good? Avneet, that is all we expect to do. This is something we are demonstrating so that you can visually see when you really change something, practically what happens. So it is not a straightforward exercise. Certain things will have to tweak, certain more overriding decisions will have to be taken. That is why we picked this as a point. Are we good? Others, are we all good? We move on. Monica, are we fine? So I close this as well. And then move back to, no, I need to do a new share. Then go to where I were. That's where I am. Okay. Now let me ask a question. IKEA, they moved to China. They went to China. They decided they want to set up facility in China. Strategic decision. That's a network optimization. If they want to know where in China will I be setting up the facility, that is what gravity location is going to answer. Apple, they are moving Foxconn, moving to Taiwan, moving to India, answered by network optimization model. Where in India, Foxconn, where in Taiwan, Foxconn is gravity location model. Samsung decide to move to India, network optimization, where in India is gravity location model. Are we clear with the example and the application? If yes, we move on to the next real case example. Jebel Ali to Dammam. Where is Jebel Ali? Here. To Dammam, here, 900 kilometers. Jebel Ali to Riyadh, 900 kilometers. Why? Jebel Ali to Dammam is like this, to Riyadh is like this. Jebel Ali to Jeddah is 2000 kilometers. You can also go around the continent and by sea. Takes longer, right? Question is, no. Where will you set up the Will you set up the DC in Dammam, Riyadh, or Jeddah? What all information do you need? Does it tell you the demand center? Yeah. Central location look to be Riyadh, correct? Central location look to be Riyadh, right? And then, yeah. So is the volume given here? In the absence of the volume method, you are right. Geographically, it looks to be center. Yeah. So don't we need the volume? Don't we need the, yeah? And then we need the logistics cost as well. See, if I am taking a look at, yeah, exactly. If I'm taking a look at, not even telling anything, if I'm straight away looking at something like network optimization model, then I will be needing the facility cost, the fixed cost, the variable cost, transportation, etc. Once I decide I'll stay here or go here, that is when I get to the gravity location model. Dammam is close to port, exactly. Now, Mario, when you talk about the port, see, that is where you're talking about a very, very valid point. You're right. That is something called as a factor rating method that we are not covering here in the analytics part of it, right? Because closeness to port is not something that is in the scope of any of these methods in the analytics. So that is where you need to be taking that overriding decision. You're right. Very valid point. I hope everybody is able to see Mario's comment. Mario? Okay. Yeah, that's the point. Okay, so that's only this was a real life scenario. And when we did it, based on the volume, we had to locate it somewhere here. Guayfat is anybody working in the subcontinent would know. Abu Dhabi, 300, 400 kilometers down the line, somewhere here is where we'll be having this place called Guayfat. And then we need to set that up there. And then it's a place of no man's land. You can't set up anything over there. So we decided maybe we can set it up here or here. But Mario, it is a complex country. So we decided we'll stay here alone. Got it? Real factor rating method. But when we put all the data, it was coming somewhere midway here. Not even Dammam, not even Riyadh. Okay. Right. Okay. Before we get to the route optimization, maybe one small topic. Some of the issues of, see, we are talking about, the place. You have the plant. It goes to DC. Maybe I think this looks to be Goa. And from Goa, it is getting to various stores. Okay. And then trucks are taking, various trucks are taking. That's the route optimization that we'll be taking a look at. See, why is it important to have optimized network? Because when it is a sub-optimized network, it has higher lead time, takes longer to reach the customers, increased forecast horizon. See, when you really talk about a longer forecasting horizon because of increased lead time, more inaccuracies within the lead time. Go back to a root beer game. 4 weeks is the period. Forecasting horizon is 4 weeks. Demand changes, you can adjust up, you can't adjust low. That's the next point. Low flexibility, longer lead time, longer horizon, low flexibility. Because of the low flexibility, because of demand and supply variability, you have to keep higher inventory level, which leads to obsolescence, write-off, cost, etc. That is the reason for us to keep the network in an optimal manner. Now, we need to now take a look at two other models which is related to it. What time is that? 8:20. We'll open it and then stop for a break at 8:25. So, having covered network optimization and gravity allocation, we are now going to be talking about two other models. One is route optimization. When I have to send goods to various customers, what is the optimal route that I am going to be taking? Next one is that when I have some existing facility, from which facility do I supply to different places? If you take a look at, like a simple example of postman or postwoman delivering the post or the parcel, they have a route. Depending on where different packages have to be delivered, they have a route to be taken. Ideal route, the shortest route, that is a route optimization. One. Number two, when you place an order on Amazon or Flipkart, do you always get the goods directly from the plant, or many a time you get it from the intermediate warehouse as well? What do you think? Do you get it directly, or is it somewhere from intermediate? Right? That's a facility optimization. From where do I ship to? Is it available here? Yes, ship from here. Not available, ship from the nearby place. Not even available, ship from the manufacturing plant. If it's a plant, don't ship it through the warehouse, ship it directly. If it's from the warehouse, go to a sub hub and then go from there. That is about a facility allocation. Those are the models that we want to take a look at next. And yeah, okay. Can we take a break? 8:22. I think it's okay. We'll reassemble at 8:30. Okay. All righty. Shall we continue then? So you all have any session tomorrow or so weekend relaxing? Sunday you have session, so tomorrow's okay. Good. Others? HR analytics. Okay. That's Sunday. So tomorrow's fine, free, huh? So Sunday probably it's the morning, isn't it? Okay, good. So simulation, when is it due? This week or next weekend? 14th. Oh, so that's something that's, oh, lala. Okay, okay. And then Jason, I think you were the one who reached out. Then please write to the support team. Huh? So in case the second one is not opened up yet, when you have a submission this Sunday, looks to be tricky. So please, yeah, please. But did you get any update about it? Have you all sounded out about that, or that's, or is it something that you notice now? Did any of you notice it earlier, or is it noticed only now? Jason, others? Recently. Okay. Okay. Please reach out to the team, either one of you or a couple of you, so that they pay attention to. I'll also sound it out parallel to someone, but don't wait for me to sound out, please. Okay. Okay. Then please sound out to you write a proper, like whatever is a ticket you need to raise, then go back to them. I'll also put a text to someone. Okay. Good. That's fine. Yeah. Please, I think good, Vishnu. So please go through them. Then probably they will reach out and then see what needs to be done. Okay, good. That's fine. Okay. With that, let's try to take a look at the route optimization and the facility optimization. The route optimization, another example is Uber, Ola, right? Wherein they, depending on where the call is coming from, whoever is really booking a cab by the app, whichever is the near one, you normally get option, right? Depending on you want a larger one, a share one, a premium one, whatever it is. So it shows and you can pick the one. So whatever is nearby your location, that is what really pops up as the available one and shows the nearness, how close it is to where you are. They choose the optimum route of reaching out to you. This has its origin to one concept called as a traveling salesman problem. What is traveling salesman problem? When people have to make multiple calls in a beat, right? They have to make the travel plan in such a manner that they're starting somewhere and multiple options are there. Can go from here to here to here to here and then get back. This is 21 units. Okay. This is the best option. How will we know? We'll have to then check out, is there any other option possible? I start from here, go here, here. What difference would that make? Here, this one, and then it ends here. In case you have to get back here, then probably it is even longer. If the journey ends here and the next journey starts from here to somewhere, then this is more optimal. Yeah, 19 units. Is there any other option possible? Yeah, which talks about from here to here to here, here, right? Likewise, ending here. So that is coming to 18 units. So among the three options that was tried, this looks to be the optimum one with the minimum unit distance. Yep, about 18 units. Now, is this solution of 18 units, do you really see any limitation in this, or is this perfect, flawless? What do you think? Is that okay? Or any issue? Quick. Any issues spotted here, or is it fine? Correct. There can be many, but the point is, yeah, absolutely, Avneet. Jason, you're right. But then here the assumption is that Manoj, and hi Manoj, how are you? Manoj, Avneet, as you mentioned, like, is a person, the one who you want to meet, are they available to meet you at that point in time? Maybe they are, their time is given, or probably they're not even there, right? Then either you need to knock it down and see that subsequently, or you have to, yeah, exactly, re-optimize it. You put a condition, oh, I can't go here. Probably I have to go from here to here, and then move on. Okay, that's fine. Or you go here and then work the other way around. Then it may not be the 18 minutes thing, maybe it is 19 minutes, but given the limitation, that's the best option. Got it? All right. Now we'll have to take a look at the route allocation, the steps, just like how we did it. They're all probably taken from the same thing. So what I really wanted to think is that, of course, you need to understand the demand center, supply center, facility, cost, GPS location and all, depending on network optimization or, like a gravity location. But what will really help is that keep this, but think logically, then it will be clear. Because I don't expect you to be writing exactly the same words, but please, you need to be, when I'm talking about the fixed cost, you need to write fixed cost. You can't, just write something else and then leave it to my interpretation. So you need to just demonstrate that you understood it. That is fine. So here also the same way. What is the whole thing about demand center, supply center, network? Keep in mind those three things. Okay. Again, you need to add route optimization is what? What is the optimum route you're going to be taking? Which means that there is a supply center, there is a demand center, there is a route. We are talking about a load and we are talking about a cost. Correct? Okay. For that, you need a what do you call a resource as well. So there's a cost related to that. Okay. Identifying demand quantity at various locations. You need to know which are the demand center, what's the quantity demanded. Number two, identify the supply location and what is the supply capability. So you have a supply location. I want 10,000. Nearby supply location is only 5,000. 5,000 from here and 5,000 from somewhere else. Yeah. So supply availability and the location. Then we are talking about what? Optimizing. So we are talking about what is the, just like the previous one, coordinates. Where is the supply location? What is the coordinate? Demand location, coordinate. Okay. Because we are talking about optimizing the route, we are talking about a resource. Here we are not talking about setting up a facility. Here we are talking about moving the goods. What is the optimum route? So is it actually a 3-ton pickup, 20-ton pickup, a 100-ton flight, or whatever it is? Okay. Then you try to find out the linear equation considering any constraints. I don't have the facility, or I have only limited capacity, whatever it is. Yeah. So that is what is physical, what do you call, route allocation is all about. We'll see that in the example. See, so from the facility manufacturing, it goes to different places. From the plant, it goes here to here. Let's say that this is not there. Maybe it is going to here and then supplying all this area. You can take a look at various options. Sorry, questions. Only visit place once. Yeah, good point, Mithal. If you really add that as a limitation, then that's an issue. But if you remove that assumption, it might be a different thing. Correct. Yeah. You can put that as a limitation, then it will be a more sub-optimized one. Less number of limitation you put, better it is for the model. Okay. Right. Okay. Before I move here, let us talk about the Excel file. Okay. In the route optimization model, we are talking about, you have the DC in Maharashtra from where goods have to be moving, right? And then talk about Mumbai, 13 units needed, Nagpur, let's say 10 tons needed, Pune 8, and Nasik 17. So total demand is 48 tons and your truck capacity is 30 tons. Okay. Now, remember we were talking about the coordinates. So we need to understand the coordinates. It is only at the back end. I don't want to be remembering it because a truck could be going. What is our objective in the route optimization? The route optimization, what's the objective? Absolutely. Minimum distance travel. That is what we are trying to do. That is why, is it better to go to Mumbai, Nagpur, Pune, Nasik? Or is it okay to go to Nagpur, Pune, Nasik, and then Mumbai? That is what we are trying to address. Okay. Right. So here, Manoj, yes, you are right. Even when you talk about route optimization, our assumption is that lesser the distance traveled, lesser the cost. Okay. But it might not be the case all the time. You can add, like a cost aspect as well. We have not added here in this simulation, but it is possible. You're right. Because object eventually that is what it is. Right. So here we are trying to see the distance between each and every point. Okay. Let's move on. So we are talking about this. So when my demand is 48 and my truck capacity is 30, do I need, can one truck do the job or do we need two? Do we need two? Right? We require two. Let's try to see with this 30 ton, what's the best solution? Okay, with 30 ton, what is the route? From DC to Mumbai to Pune. From sorry. From DC, you have a truck going to Mumbai, another truck going to Pune. Mumbai truck goes to Nasik. So Mumbai, Maharashtra DC, Mumbai, Nasik. From Nasik, it goes back to warehouse. So Maharashtra DC, Mumbai, Nasik. Maharashtra DC, Pune. Pune to Nagpur. Nagpur to Mumbai. So DC, Pune, Nagpur, DC, Mumbai, Nasik. Those are the two trucks. And we are getting, don't worry about these things. It's only really for the purpose of calculation. Don't worry about it. So with a 30 ton pickup, 48 tons to be delivered to the 4 location, this is how it is outlined. And you're getting 812 kilometers. Let's actually put it 30, 812. If I put 20, will I get a different number? Oh, no, I can't put 20. If I put 25, will it be a different number? Can we try it out? So 25 is not a good idea. Huh? 812. 25 is what? 922. Okay. Yeah. 40. 40. Well, logically it doesn't look good, but let's see. Wow, interesting. 40 is better. Do you see that? 40 looks better. Why? Maharashtra DC to Nagpur to Pune. Nagpur to warehouse. Okay. Okay. So there's a truck going from Maharashtra DC to Nagpur and back. The one to Pune then goes to Nasik, Nasik to Mumbai, Mumbai back. Very good. So Pune, Nasik, Mumbai back, Pune, Nagpur back, 732. Interesting. Yep. Pune direct, that's also possible, but here it looks to be different, Manoj. Here, Nagpur and back, Pune, Nashik, Mumbai back. So which is the most optimum one? 25, 30 or 40? Hypothetically, if 50, will it be more optimum? Hypothetically, if we have 50, can we try that? Hypothetically, we have a 50, then it's only one, right? I hope so. Let's see. $725, yeah, marginally it is better. Marginally it is better. But now, is it better to have one truck or is it better to have two trucks because it's only marginal advantage? Maybe I can be more, you can even talk about, delivering it quickly, right? One truck hauling all the way, their working time, 725 kilometers. Yeah, so maybe it is worth, although distance is longer, for the sake of the time as well. Are we okay here? So this is not the exactly less lead time, correct, Krishna Kumar, right? And that's much, well, chosen solution. There's nothing right or wrong. It's a chosen solution depending on what are we looking at. So maybe it's a suboptimal decision, but that makes sense because of the lead time. Okay. So let's close this one and try to talk about the lead time. About the lead time. Where is the lead time, Funda? Lead time. Now we are going to, when we talk about lead time, we are talking about two aspects, responsiveness and efficiency. Responsiveness refers to the ability to handle demand uncertainty, having shorter lead time and higher service level. So you are able to respond quickly. 40-ton truck, 50-ton truck, responsiveness is low. 30-ton truck, responsiveness is better than, I think, 40, I believe, right? Because 30 was going to two places, 40 was going 1 and 3, 50 was going all the 4. Okay, so you can choose between both. Efficiency wise, probably 50 tons was better, wasn't it? Efficiency wise, 50 tons was better. So we can try to balance responsiveness and efficiency and see which one is better. Are we clear? And here, very quickly, I will cover the responsiveness and efficiency Funda, and then you can try to go through it. I'm not just talking about analytics. These two things are quite pivotal in many aspects because they really go hand in hand, as in they are in contrast to each other. There is a need to balance both of them. Let's try to understand the primary goal of both of them. Primary goal of efficient supply chain, you keep the cost the lowest possible. Responsiveness, respond quickly. I really want to satisfy the customer. Product design, what is my objective? Minimum, maximum performance, minimum cost. Responsiveness, I'm not talking about the minimum cost. I'm keeping modules, different components ready. Mix it up and give it. McD kind of a thing. Yeah, Pizza Hut and even Subway, Toyota, Dell, IKEA. They are all talking about modular design, responsive supply chain. Pricing, low margin, and here we are talking about higher margin. Why? Because responsiveness is my strategy. Quick service. So whoever wants quick turnaround will come to me. They'll be willing to pay a bit of the premium. Inventory, minimum inventory cost in the efficiency. Efficiency is all about the cost, keeping it as minimum as possible. Responsiveness, buffer inventory. Why? To deal with demand supply fluctuation. This need not be the finished goods inventory. This can be the module inventory as well. It can be a raw material inventory. It can be capacity inventory. Okay, so take in a broader sense. Lead time strategy: reduce, keep the lead time as low as possible, but don't reduce at the expense of a cost. So even if I have to, reduce the cost for a longer lead time, I am okay with that. But what is responsive supply chain? Even if I have to pay extra, I keep the lead time lower. Why? Because I am responsive. Here I am responsive, but cost is more important. So I give priority 2 to responsiveness, priority 1 to cost. Supplier strategy based on cost and quality. Here, quality is there on both of them, but I'm not looking only at the cost. I'm rather talking about the speed, the flexibility, the reliability factor, etc. That's efficient supply chain and responsive supply chain. Very important to understand. I'm not talking about the term and examination or whatever it is. In today's world, two important aspect that organization trouble to keep in balance is how quickly can I respond to the customer and how can I keep the cost minimum. When you talk about responding quickly, your cost goes up. When you try to optimize the cost, your responsiveness takes a hit. So you need to try to balance both of them. Any question on this? Any question? Amit, Jason, Krishna Kumar, Manoj, Mario, Mithun, Mithil, Mohit, Monica, Prakhar, Surajit, Vishnu. Okay, good. I know it is end of the working week. It's 8:50 past, so not so easy. So bear with me. I think we'll finish. Should be good. Okay. I don't think so. We have a long way to go. Probably most of the complete. Exactly. These days, Krishna Kumar, because people are also much more looking at speed. The patience level is low. Visibility is high. Options are more. Customers are willing to pay a bit more. That's a tendency, new generation, new customer, like the new reality. Willing to pay a bit more to keep the queue shorter is a tendency. So when we really have our visas or the passports to be renewed, there is something tatkal service, a quick service, quick response service. You pay more, you get it done. Why do you really want to wait it? You're not doing anything. It's only about you pay more, you really get it in the next day. You pay less, you get it within 48 hours. It's only the 24 hours, but you don't really want to let go, float somewhere. So the tendency to wait is less. Hence, you really want the goods to be back to you quickly, even when you pay more. That is a responsiveness fund. Yeah, clear. Absolutely. Correct. With less cost, correct. With optimal cost. But when you're talking about the less cost, now, when you place order through Amazon or Flipkart, which most of us could be using, the strategy they use is that you have a standard service or a quick service, right? You pay more. So they give you the visibility method. Where? And if it is something I'm not very keen on getting quickly, I might be saving the 40 rupees. 40 rupees is not so big. But the point is that, yes, many 40 rupees would make a difference, right? So you may choose a standard service 1 week later. Good enough for me. Something more important, well, I'll pay more and get it quickly. Yes, 1 week service and 24-hour service available, Mithil. Given the visibility, let the customer choose. So no hide and seek. Agreed? Yeah, correct. Long waiting time people want to avoid, correct. Exactly. Retailer with Amazon, perfect. Yeah. Convenience, come with a cost, etc. Leave it. See, this is an example wherein when you're balancing both of them, when you're talking about a response time of 1 day, then you're talking about a delivery every day. When it's a delivery every day, this is more responsive, isn't it? Is it not more responsive? Cost also goes up, correct? Take a look at the next one. When you're talking, when you're looking at delivery every second day, then cost of delivering is lesser, but responsiveness is lesser as well. You're here more efficient, but much, much less responsive compared to this situation and this situation, right? So what's the implication of these situations? I don't really want to send a discussion at this point in time. I hope the point is clear to all of you. So I'll move on because I know it's end of the work week and a simple concept, okay? Implication is that, like Krishna Kumar Mittal and who else mentioned, I think both of you, I believe, wherein the tendency to wait is lesser, then you go for this. Premium customer, go for this. More economy, cost-oriented customer, go for this option. So an organization will have to put a strategy. Go back to slide 1 today. SKU rationalization, lesser lead time, demand variability, like the complexity of SKUs, etc. in the strategy inventory part of it. So strategy that you really choose based on the customer. Is it not the same way? Premium customer, different strategy. Normal customer who is more economic customer, different strategy. That is what the cost versus responsiveness strategy need to take into account. All right. With that, we will get to the last concept for the day. And yes, we will have some time for our total cost of ownership in the previous one. What does that talk about? Here we are talking about not setting up a facility, but we are talking about a facility from where stock or supplies are getting allocated to fill a demand. You will need to answer all those basic questions as in network optimization. You are not setting up a network, existing network. You're only deciding, am I going to be supplying from Karnataka or from Goa, from Andhra or from Kerala or TN, Maharashtra? That's a question that you're going to be deciding upon. So what do you need? You need demand. 3 basic questions. What are the 3 basic questions, 3 components of the network? Components of the network. Components of network. Method. See all of them here, right? Demand center, quantity demanded, supply center, supply availability, okay? Cost per unit, just like network optimization. I have the demand center. Do I supply from Vizag? Do I supply from Nasik? Where is the customer? What's the volume needed? Based on that, you decide. But is it only that one? You're also trying to see basically, is it balanced or unbalanced? What is that? Balanced or unbalanced is really talking about you can't have a negative supply, right? Like I don't have the, I have the demand for 50 tons in Mumbai. Pune factory has only 30. When Pune shows that I am supplying everything, it means that I am now in a negative 20 stock, correct? Is that a reality? Is it possible? Because we're talking about the linear equation. So it can be either demand or limited to the supply quantity. Remaining 20 has to come from somewhere else. Only for the sake of understanding, don't need to get confused about it. So you're talking about the demand center, demand quantity, supply center, supply availability, cost of transportation, that's all. Same as network optimization. Now, we will take a look at the example and then come here. Okay. Question. No. That's not negative supply. That's not negative supply. See, when you're talking about a linear programming, linear equation, what happens is that when I want to supply 30 and I have only 20 in stock, an equation will supply and it will show, it will say from Pune, I'm supplying 30 and I have negative 20 in stock. Yeah, that is where you're talking about negative supply. The example you are giving is not negative supply because in reality, you're doing something about it. That's okay. That's okay. Negative supply doesn't really happen. It is only in the Excel or even the, yeah, not only in Excel, in tools it happens. You have to put the logic proper. All right. Now, the same situation. Now, this is the same as network optimization, wherein, see, you are deciding these are all the demand centers. Demand centers. Quantity demanded. Yeah. So demand center, quantity demanded. Supply center, capacity. Okay. When I talk about a supply capacity, I have fixed cost, capacity related cost. So demand center, demanded quantity, supply center, capacity of the center, fixed cost. That is, fixed cost is only related to supply city. In relation to supply city to individual demand city or demand center, there is a logistics cost. So you need to understand for every whatever 1,000 units from Maha DC to Mumbai, it is 6.3, same as earlier one, I believe. Okay. So you have the supply location, you have the capacity of the supply location, you have the fixed cost of the supply location, you have the demand center, you have the quantity demanded of the demand center. And so that is 3 points for, meaning 3 aspects related to supply, 2 aspects related to demand, and 1 aspect in combination of demand and supply is the logistics cost, which links each demand center to each supply center. Based on that, you need to be deciding, am I going to be using this location or this location or this or this or in combination in order to meet the demand? What is the total demand? We are talking about something like 8250 units, whatever. What do? We are talking about keeping the demand as low as possible, meaning that keeping the unmet demand 0. Let's try to do the solve, say okay. Alrighty. So what are we doing about here? You are engaging Maha DC and 4167. Okay. Supplying to Mumbai, Jaipur, Udaipur. Karnataka DC supplying to Kolkata and Bangalore, 2250. Partially. That's no. Oh, 3250 fully, but there's some excess capacity, doesn't matter. So see, there's an excess capacity here. And Rajasthan, we are talking about supply to Delhi and Udaipur, which means that Udaipur gets supply from Maha and Rajasthan. Delhi gets from Karnataka and Rajasthan. Okay. Unmet demand is okay. Cost is 140,783. Okay. Now, this is the optimum solution. If we add any condition, will the cost be less or more? Let's say that we add some condition. What will happen to the cost? No. It is only not closing. Here, we are only talking about engaging it. So we are not utilizing that DC in this particular month. Now, let's say that, whose question was that? Let's say that next month, my Rajasthan depot is in some kind of a maintenance. So I can't use that. Yeah, let's see what happens. And I want to use the Kerala one. Let's try to do that. Data. Solver. I16 is equal to 0. I16 is equal to 0. I put I16 is equal to 0. I'll put change I17 is equal to 0. Say okay. Say okay. Solve. 156425. Keep the number in mind. Oh, I think it was a new one. Doesn't matter. See, now equation changed. I'm keeping this as 0. The cost changed. DC has more. This is a more suboptimal one. So we're not closing it down. Yeah, correct, Manoj. You're right. You have a tendency, you itch. Yeah, I'm from Kerala, me. So I want to use it. That's not a good idea. So I use it. That's the whole thing. It won't really work. Yeah, Manoj, better. Kerala put constraint. I removed it. Actually, let me put let me remove all the constraint. Then let's see what happens. I don't know. I don't recall the result. Let's do that. Can we remove this? Enter, delete, solve. Oh, then what happened? Still, I don't think so. Result change. Whether I put Kerala as 0 or otherwise. Yeah. Unfortunately. COVID we still hold, but not this warehouse. No, Manoj, Mithal, like jokes aside, no. Even when I remove that location, yeah, I removed it. Mithal, I removed it already. Yeah, see. But then it doesn't still change the situation, because with or without that, limitation, that still is the best one. Yeah. Maybe last run probably we tried something out. That is why I put there. So, but yeah, you're right. Okay, good. So that's facility allocation. So we are not, so to go back to your question, Mithil, we're not closing the facility. It's a question of whether we engage the facility or not. Maybe it's a subcontract facility. Okay, we have some facility, let's with DTDC, and the month I avail it, I have to pay them some charge. But then that's more an open contract. I can avail in Maharashtra, Karnataka, Kerala, or Rajasthan. It is only depending on where I use floating thing, right? Where I use, I pay only for that. So it's something similar. Okay. Any question on this one? I think now we'll go back to the example, so it might be more clearer. So I'll stop this, close this. Then let's go back to the example. Tangier, another actual situation. Good. Now, this is that Tangier facility I was talking about. I was proudly part of it to set up 500 pallet spaces. Trust me. 500 pallet spaces is a big warehouse or a small one? Is it big or small? 500 pallet spaces is big or small? Not big. No, I think Manoj, you're being liberal. No, it's definitely not big. No, Mithil, it's not. It's not. Well, depending on the organization, but I'm talking about 3M. Sorry. Apologies. I'm talking about a company called 3M. For the size of 3M to supply to the entire African. Yeah, correct. Sorry, apologies. I didn't mention, or is it mentioned somewhere here? No, sorry. No, maybe 500 is big. If for a town where I am, 500 is bigger. It's definitely a massive warehouse. You have a small town, that's big. But for 3M size, supplying the entire North Africa, it is not. But then we were getting the goods from Belgium, Germany, even France, and then getting it across. Massive DCs, you can get anything from these places. And it's Franco-Linguan, so they really get Franco-Anglais, so they really get it, the goods that they really want. Set up a warehouse in a free zone. Goods were what used to go directly, used to come here and then go. That was the model. Okay. So now this is about facility allocation, isn't it? What used to come directly, now you are coming here and then allocating it, correct? Is it not facility allocation? Manoj, Jason, Mithil? Facility allocation, correct? Now, yeah. But then what really happened was, it was not a matter of cost. It was costing more, frantically. But then we set it up to show the country that we are putting a hard investment here. Why? Wanted more people, recruitment. We wanted to have contract with many companies over there. Some of the companies here as well, small, upcoming one. retailers to trust, saying that, hey, we are putting some stock over there, Manoj. But what really happened was you could not put all the stocks here because smaller countries, multiple items, large variety, you're not able to even get 20 items. Trust me, I was part of that project leading that. I couldn't even get 20 items that is commonly bought by all of them every month. There were items that they buy in good quantity, in frequent delivery, or different packs, not working at all. We put some stock here forcefully because you have a pallet, you need to be pallet space, you need to put it. Then you had to still customers continue to buy directly. Why? When they were getting through here, cost was more, no, and you're not getting even everything from here. Got it? So that's a point when you have a facility, but you're not able to use that facility because there are other overriding factors. Got it? So yeah, it's good to have. So like Mario or somebody asked, the factor rating comes into play. And Jason or whoever mentioned about the psychology part of it. Yes, it is a very important aspect. Even if when you really have a facility, it doesn't really mean that retailers will switch because they take a different picture, bigger picture. Got it? Yeah. All right. Now with that, we can get to the summary and then we can go back to the total cost of ownership. Summary, we are understanding the supply, meaning what we did was basically what is a supply chain network, which is about a demand center, supply center, and the distribution network. What are the different parameters that really control the supply chain network? We are talking about, various aspects of the demand variability, SKU, right? Portfolio, the cost related, etc. Then what we looked at was we looked at facility optimization model, which included network optimization and gravity location. Then we looked at route optimization, and we looked at the facility allocation model, right? And very important thing is that we were also taking a look at responsiveness and efficiency trade-off, the dissect that is there, which you need to be trying to keep the balance in place. That is what we covered today. Correct. Manoj, I think that is possible. But then what happens is that when even we tried it, Manoj, wherein we can have the goods, even if customer places the order for items not stocked in Tangier, you can actually route the shipment through Tangier, the warehouse, combine it with the goods that is, in stock in Tangier and ship to them. It was a long haul, cost was higher. That was the issue. So only to utilize the facility, I think you mentioned already, you're right. I think it's increased cost is the issue. Correct. Sorry, I didn't read your comment. Yeah. So that's the thing. But we can use it when we tried to use it in many ways. Whatever we were using was leading to increased cost. Why? Because we took a decision not based on the cost. We took a decision based on some other factor rating, to have a facility, to have a footprint, to show that we are here as a brand. So when you take a decision based on a non-cost background and you compare it on a base of cost, you will never be able to get it. Yeah. All right. So before I say thank you, we need to go back to previous one and take a quick look at total cost of ownership. Give me a second, please. No. Before I share, one is total cost of ownership, and number two was talking about all right. What pattern do we expect in? Yeah, sure. Amnit, I think we covered it. Give me a second. I'll just cover it quickly, and then we'll go back to cover that point, those points very quickly. So Able to see my Excel? Yeah, right. Now we are talking about buying television set 20 quantity from 5 potential, let's say, distributors. And this is a unit cost with each distributor, or let's say that they're manufacturers, forget about distributor. Each and every one is giving different terms of payment. Company A is giving 90 days credit. B is asking for advance payment. C is talking about 30 days credit, so on and so forth. Okay, right. This is a unit cost. And so that's one. This is a product cost, payment, delivery cost. Delivery for, like A is you pick it up. B, C, they deliver. D, E, you have to pick it up. Yeah, maybe it's a cost is low. That's their policy. Quality compliance. When it's A is about 92% quality compliance, meaning there's an 8% potential defect. B, 5% defect. C, 4%, etc., etc. E is 90%, 10% defect. Let's say that you're only taking a look at the unit cost. Which one will you go by? Who will you go by? You take a look at only unit cost. Who will you go by? E. Good. Yeah, fine. Now, let's see, will our rating change based on the calculations? E is asking for advance payment. Okay, so you don't get any benefit. 90 days credit, what does it mean? You pay only 90 days later, isn't it? Yeah, so that much money you can actually circulate, right? So practically speaking, at something like what 1.2% for 3 months, that is coming to 1316. So although it costs 37,000, it's practically only costing you 35,684. Are we clear here? Are we clear? Yeah. Okay. Now delivery cost. Who's delivering? All these people, zero delivery cost. Delivery cost only 150 rupees. Still, A, D, and E, we are having to incur a cost of 150. Now we are talking about a cost of, this is funny though, but still, we are talking about a cost of 50 rupees for a reorder cost television. Maybe they're replacing it. They're replacing it. So you're talking about 80, 50, 40, 20, and 100. Is it possible that, 2098 is talking about 0.4 television? Is it possible that a 0.4 television gets defective? No, right? It's either one or none more. Anyway, doesn't matter. We need to tweak it, but that's okay. It's only to give you the concept part of it, right? So when you take a look at this, this is a reorder cost part of it. So 50 per unit is what we are talking about. Now, if we add all these things, that comes to the total cost of ownership. We have only added 3 terms. Maybe there are more: replacement, maintenance, whatever is a spare parts, etc. Right? So based on the total cost of ownership, which is end-to-end cost, life cycle cost, we are talking about 35,914, 35,050, 35,613, 36,237, and 35,000. Who will we go by based on this? E, right? But is E a conclusive decision? No. What else can we take a look at qualitatively? B, very close. And B, Manoj, since you talk about B, B has a very clear quality compliance advantage, right? B has a very clear quality, yeah, compared to it. See, for a 50 rupees extra, it is actually a good 5% point improvement, isn't it? And that makes a lot of sense. Meaning, it's only an example, but only take a look at D. Hold on. What is the point with D? D is 36,237, possibly the highest in the total cost of ownership, but they have the best compliance. Yeah. So now, Krishna Kumar, we can actually choose between D and B. It can be a debatable question. Are we okay to pay so much extra, or can we not go by the least total cost of ownership, but one that is slightly higher for a better quality compliance? That's a debatable point. iPhone debate about which model? Correct. Defect will be on the dental quality and the price. Correct. Yeah. So it's only to demonstrate the cost of the total cost of ownership, a very strong concept as well, wherein you don't go by the purchase price alone. This is a purchase. Here, logically, again, maybe I should tweak some number to change the result. Here, what practically happens is that E happens to be the choicest, even with the total cost of ownership. But the quality really takes a hit. Maybe I should change that number. Yeah. Absolutely. If I really make it bigger, instead of 50, hold on, I make it something like 500. Oh, don't tell me. See, now this became 1, 2, 15, 3, and 5. Okay, right. Clear? Exactly. C is the closest third. Correct. C is the closest third. Absolutely. 35, 500, 900, 973. Wow. Absolutely. It changes. So when you really tweak a number, maybe I should make it as 50. I think this is a better suggestion. Thank you. Whoever did it. I think Manoj? Manoj. Yeah, thank you, Manoj. Saved a lot of later rework, because I can keep it for the next session. This is a lot better. This shows a difference, by the way. Correct. You're right, Kashukman. Okay. So basically, that's the total cost of ownership. Now, I'll stop here without much of delay. Let me try to answer the question, Avneet. Avneet, by the way, I owe you 2 answers. While I open this, I'll tell you those. So for the UCM, that is also a model similar to that is also similar to ARIMA, which identifies, trend, seasonality, etc. It's not coming up. Trend, seasonality, etc. Yeah, this is one. And number 2, you were asking about was, in the Delphi method, the low high weight again is done based on the qualitative parameter. For certain aspects, they wanted more weight, and some a comparatively lower weight, depending on the attributes and the parameters chosen. That again is part of the initial Delphi method planning to have some idea on, let's say, that expert opinion given higher weight, people who are non-expert lower weight, only to get more representative result, for that not to be get clouded. That's the point. Yeah. Is this visible? Is the slide visible to all of you? Avneet? Yeah. See, it's going to be 3 caselets of 20 marks each. You have 40 marks for your simulation. You have 60 marks for your term and examination. There's going to be 3 caselets. Caselets could be something very simple. If I were to take an example of Samsung, so I could be talking about Samsung thinking of moving away from China. They are looking at setting up a facility somewhere in the region, right, to cater to demand of, let's say, India, China, Sri Lanka, Vietnam, near European countries, etc. And I could be asking you to describe network optimization model and gravity location model and apply them to the situation. Yeah. Avneet, you know what? Actually, in this particular, I know which one you're talking about. See, when you really have two parameters, giving both of them same weight gives them the equal weight. It then doesn't really make any sense, right? But sorry, let me stand corrected. It doesn't really mean that it makes no sense, basically. It gives them the equal weight. But there can be a situation where I want to give a higher weight to one parameter, just like a factor rating method or whatever it is. Then you can use that too by changing the weight. That's it. Yeah, when you're giving both parameters the same weight, then they are treated equal with weight or without the weight. Maybe the weight is only for the purpose of calculation of the further scores. Because if you put a 0, then there's no calculation. And so you have to put 1. Yeah, exactly. No numericals for the term end examination, no calculation, no Excel whatsoever. Okay, moving on. Yeah, moving on. There can be what is expected is that you read the case situation, apply the concept. There will be very clear question on the concept. You have to describe the concept. Question will be clear. Describe a network optimization model, or maybe it is talk about describe facility optimization model. Models, when you need to be talking about network optimization and gravity location. Yeah, so be careful with the question. Yeah, read it properly and apply it. Mark breakdown will be there, some for theory, some for application. There is no twisted question. It is all straightforward question, as in not exact theory. It's an application based question. So there can, when you really talk about it, 20 marks, maybe there's, like about 6 to 8 marks weightage for theory and 12 marks weightage for application, roughly. 20 to 30, 20 to 40 marks weightage can be for the theory. So you can describe the theory, the steps in the model, what is the model, and you apply it. Application definitely gets a lot more weightage. It will be given very clearly in the question. Focus on the topic in the question. So when I'm talking about, let's say, total cost of ownership, focus on that. Don't really get into minimum order quantity or economic order quantity. When I talk about inventory models, like maybe you can talk about or inventory classification, that talk about the classification, not about EOQ, MOQ, or like reorder point, etc. Stay within the topic as much as possible for your sake of time and completion. Have some structure, introduce the concept, apply to the situation, logically explain. So when you talk about I will be setting up in India, explain why. Without the number, logically, I will take a look at the demand for these places. I'll be taking a look at the supply for these particular places. I'll take a look at, the quantity, we were talking about this, the cost of the fixed cost, the variable cost, and I might be choosing India. My choice space is India. Then within India, where to? That is what I'm talking about, the gravity location model. What is that particular model? What all you consider? Based on that, I consider possibly Noida as a better place. You can conceptually talk. Okay. Title, subtitle. It's not that you have to write title, subtitle. The point is that maybe the questions are coded as 1, 2, 3, ABC, AB, 1, 2. Put that. And if it's gravity location, put that. If it is a description, leave a line and get to the next one. So I can spot your answer properly in a clear, crystal clear manner. That's all. Now, are we clear with the pattern? Avneet, others? Now, very clearly, very quickly, these are the topics that you can focus on. Everything we have covered: forecasting methods, quantitative, qualitative, accuracy measures. We looked at MAPI, WAPA, not WAPA, sorry, MAPI, MSC, like MAD, and roles of inventory, classification, safety stock, MOQ, EOQ, total cost of ownership we covered today briefly, facility optimization, which is not network optimization, gravity location, logistics, network optimization, facility allocation, route allocation we covered today, responsiveness, efficiency we covered today. So these are the concepts. If you go through all these things, be familiar with them, you are in good shape. I think everything, nothing is here that we have not covered in the live session. Are we good? Mithil, Shashank, okay, is currently having limited access. Is there any backup option given there? Right, let's see. Let's see if I can help you here quickly. Give me a second. Pranjay, do you know who is backing up Shashank while he's away?
I'll check with the team, sir, and let them know about this problem that the
Please,
learners are facing.
because they're stuck
And
with the situation, and definitely I understand them because there's a timeline given, and they have the next session also on Sunday. So
sure,
it'll be good. You understood the problem, right? I think the second one is not coming up, it seems.
exactly,
So
exactly.
yeah. Thanks a lot. So
Sure, we'll do it. Yeah.
okay, thank you. So, ladies and gentlemen, we will meet soon next Tuesday, and hopefully next Tuesday. Otherwise, we'll meet again one of those days. So, Vishnu, Surajit, Monica, Mohit, hi, good to see you. Mithal, Mithun, Mario, Manoj, Krishna Kumar, Jason, Avneet. It was really fantastic. I know that the day one when we opened, you were all working hectic for the exam. After that, it was quite interactive session. Day one, even I was really wondering, I somehow had complete. If you have any question on the day one, please get back to me. Feel free. And Avneet, I believe we have covered those two questions that you had. But please, if there is any area, then we can answer. Any other question? I think I've covered everything. If there is anything that is not covered, please shoot a question in our post section, and I'll be more than glad to help you. With or without the question, even when you're preparing for something, when you really come across any doubt that you want more clarity on, feel free to reach, and then we'll be more than glad to support you over there. Good. So with that, exam will be quite comfortable. Focus on these points. I'm sure that you will all do well. So it should not be a source of worry for any of you. And beyond the examination, do well for rest of your course, for your career, and for your family life and work. All the best. Yep. So you can reach me. Narayanan is my LinkedIn. Yeah, will be glad to be in touch as a part of the professional circle. Okay, so all of you do well, all the best, and we'll meet again, right? Once anyway for the debriefing we'll meet. So do well for the simulation as well. Okay, so good night, Pranjay. Thanks a lot. It will be great. Appreciate your support, Pranjay. So if you're able to give a heads up to whoever within the institution about this particular small hitch that we are facing on the simulation, that'll be really great. Yeah.
Sure, we'll do it right away, sir.
Appreciate that. Appreciate your support. I'll exit. Okay. Others, good night. You all take care. Pranjay, thanks a lot for the support. Good night.
Thank you, Professor. Good night.
Bye.